Good afternoon again, everyone, and welcome to the third part of today's automotive session, vehicle homologation with CAVA and LiteCar. And when we were planning this automotive session, we were thinking throughout, okay, how can we link one session, part of a session, to the next? And so far we've spoken about vehicle modeling and its use within driver simulators. We then moved on to using similar vehicle models for autonomous vehicle testing and development. And those autonomous vehicles will have sensors installed on them, whether these be cameras, lidars, radars, and so on. And so part of the work that we don't really touch on at Claytex is how these sensors are positioned on the vehicle and whether they still comply with requirements for the vision that they have, depending on how they've been installed, to guarantee the controllers what it is that they need to be able to take in as a data stream to understand how a vehicle is behaving and positioned and so on. So tools such as CAVA can help with that type of check. And so that's just one of the things that it can do for the users. So I'm going to pass over to Wolfgang Klemm from Technia to take us through vehicle homologation with CAVA and LiteCar. Thanks, Wolfgang, over to you.
Excellent. Thank you, Alex, for the intro. So, yeah, I'd like to introduce myself. So my name is Wolfgang Klemm. I'm the product manager of the product CAVA, and I'd like to give you a presentation about. Okay, coming back to my presentation, I'd like to give you an intro about the topics of the presentation. I would like to give a small introduction about CAVA, what the product itself is. And then I want to go into the area of how CAVA can help you in the autonomous and assisted driving. So some challenges in the vision analysis in that area that CAVA can assist you here. After that, I also would like to talk about the other legal requirements for indirect vision in automotive vehicles in general. I'd like to show you some intro, what CAVA can do for you in that area. And yeah, after that, we also move on to another area of CAVA and also the LiteCar product, where we will show you the capabilities about pedestrian protection and occupant safety. So, what is CAVA? Yeah, CAVA is a product for vehicle compliance. And yeah, vehicle compliance is a compulsory part of the automotive design. Without compliance to legals, you won't be able to homologize your car, and it would not be allowed to drive on the road. So CAVA, which is actually the name is an abbreviation for automotive extensions for vehicle architecture. Yeah, that provides a solution that can let you easily and confidentially validate the compliance of your vehicle design against various standards and regulations. The product itself is available for CATIA V5 and also for the 3D Experience platform. Yeah, and it has already widespread use at OEMs and suppliers, from many different regions in the world. So some benefits of CAVA, it is deeply integrated into the CAD system itself. So this has some benefits like the designer can use the function similar to the function he knows in the CAD system, and as well the analysis data can directly with the CAD model data, and it's stored also in the CAD model data. So whenever any design change may happen or input parameter change might happen of requirements, the CAVA analysis can be automatically updated easily directly within the CAD data. CAVA is also designed to be open, so it has an open architecture with respect to input parameters, output parameters, but also CAVA supplies a lot of international standards and regulations with the product. All these regulation standards can also be modified by the user or adjusted. So that the customized standards can also be checked with CAVA. So CAVA itself is available as the complete product, but it also is available as several products or individual products for different areas. So I'd like to mention the areas. We have the CAVA OVA product, which is for the overall vehicle packaging. Well, this will handle questions like, where do different components of the vehicle have to be placed, like the lamp positions. You can check the underfloor clearance or the overall vehicle packaging parameters. So you can easily, already in the early design phase, make analysis and get feedback from CAVA if your design or your outline of the vehicle is according to legal requirements. It's available also the CAVA mannequin module. The mannequin module helps you to verify seating positions of occupants in the vehicle. So it's placed around seatings, pedal positions, headroom, and other parameters typically defined in some SAE regulations or best practices that help you to give a good seating position in your vehicle. Then we have the module for CAVA vision. With this module, you can analyze the direct and indirect vision of the driver. This is pretty much regulated in different standards in the world, ECE regulations, FMVSS, but also Asian and Arabian countries have different regulations. So this helps you to make sure that your vehicle can be fulfill all these different requirements worldwide. I will more deep dive later in the CAVA vision when we show how to actually apply it on the automotive and assisted driving components. So next module would be the CAVA safety module. This analyzes the safety quality of your vehicle with respect to occupant safety and also pedestrians or road users safety. It includes functions like the safety radius analysis and pedestrian protection impact zones in the front of the vehicle that are required for doing the crash tests. Last but not least, we have also a module for wiper. It can analyze wiper kinematics and the wiping quality based on geometric characteristics of your wiper system. And the CAVA tools module provides efficient and very fast silhouette creation with very few clicks in highly efficient quality, high quality of complete cut products, not only cut parts. Okay, this is just a rough overview. It's a large product with a lot of functionality. So let's now focus on some of the aspects we wanted to show today. How can CAVA help you in support you when you design vehicles for autonomous and assisted driving? So CAVA is a product that is used by an automotive engineer, and the automotive engineer will design its components, and he needs some assistance when, for example, he faces some challenges when doing that for autonomous vehicles. Like he has to place several cameras or sensors in the vehicle to survey the environment. Usually it's a set of sensors or cameras. Different types can be used. It could be the optical camera, but also LiDAR sensors or radar, infrared, or even subsonic sensors. And the challenge is it must be ensured that the critical environment is in range of the cameras and sensors. And when the area is in range, you also have to make sure that it's not blocked by any vehicle part that might interfere with the camera, or sensors range. So how would CAVA deal with that? In CAVA, we call it a camera field of view function, but it is a very flexible function, and we do not actually simulate the exact output of an infrared or a radar sensor. We describe the vision of a sensor by its vision cone. So there are several vision cones you can define in CAVA, pretty flexible, so they can be subjected to all of these different sensor types. just to name a few. So the typical camera sensor, you would have just a horizontal and vertical field of view angle, which gives a simple view pyramid. In CAVA, you can easily do that. You can also specify asymmetric fields of view if you have a different angle to the left, right, or upper and lower area of the parameters. It's also possible to have vision cones with a large field, so larger than 180-degree vision, which is required for sensors that need to see the close area around the vehicle. And yes, the other types are the LiteCar type, which is some kind of rotational beacon type, so a rotating laser going up and down and moving around an axis, and he has a certain range we can detect with this kind of sensors. And to be most flexible is the custom shape. So it's possible if you have detailed specifications from your camera or sensor manufacturer about its cone of detection. We can do that either by a cross-section definition or also by using the defined cross-section surfaces that you can typically get from a sensor manufacturer. So with these sensors, then CAVA is fit to check different types of problems. Let's have a look at these use cases. So one use case is a front view. For an autonomous vehicle, it's always important to look into the direction it's driving, detect obstacles, and it must be ensured that this sensor is in a good position, and that's what the automotive engineer needs to take care of. So to give him immediate feedback if he places a camera at a certain position and also giving it a view direction and the other parameters, CAVA can display the vision cone. It can display also the visible areas on surfaces like the road surface or on other custom surfaces or on a sphere to simulate the surround view, and thus it enables the engineer to directly see if this camera is positioned, if it's pointing in the right direction. So you can also easily see if any object of interest is in the vision cone. For example, if you'd like to see if the traffic light is within the range of the sensor, this can be enabled as well in the analysis, and you get a clear indication if it's visible or not. So the analysis itself is very precise. Even for cameras that are mounted behind the windshield, we simulate the refraction through the windshield, which has a small effect, but a noticeable effect on where the first point, for example, the first point on the road is visible. Okay, let's have a look at the second view. So the front view camera is usually one camera, but for the wide area vision analysis, you need to ensure that a wide field around the vehicle is visible. And therefore, if you do it with regular cameras, usually you need a set of cameras. And in the upper right picture, you see an example of, I think it's 6 cameras here. You see the individual vision boundaries of each camera, but CAVA can also combine a set of sensors into a combined vision analysis. So the green area you see is the area visible by the combined vision of all cameras, and the red area you see is the area that is not covered by any of the cameras. So in the lower picture below, you see a similar application with a LiDAR sensor mounted on the roof. This LiDAR has a wide range and it can rotate in 360 degrees, and majorly the area of observation for the sensor is depending on what is blocked by the vehicle itself. So if you mount it more to the front, more to the rear is blocked. If you mount it more backwards, then more in the front is blocked, and you can identify the ideal height that you want to have the given sensor range of this element. And one additional benefit is all the effective vision cones, these are the vision cones including the obstructions, can be created as a CAD surface, and the automotive engineer can use this surface for other purposes, like checking if there's an intersection between other colliding objects. And so it's a very interesting capability to have this surface as a real CAD surface. Okay, I'm coming to the next area. This is more looking at the close range view. So capabilities here in CAVA are also the camera sensor view. And the left upper picture, you see a very wide angle camera, so far more than 180 degrees. And yeah, CAVA can simulate and calculate the vision cones. And as a result, here on this picture, you will see the range, the green range that is visible from the sensor. And you see it can even look a little bit below the car. So this type of sensors are important, yeah, for automated parking cameras, for cameras that comprise so-called artificial surround views, where you want to make sure that the complete area is observed and an artificial picture is generated to the driver that looks from a 3D, from the outside to the vehicle in an artificial view. Yeah, another question, which is also a legal aspect for the regular driving, is the close range vision. So there are legal requirements, for example, for the rear view camera, as you see on the right lower end picture. This camera needs to be able to see the cylindrical object arrangement behind the vehicle. So some of the cylinders must be completely visible, others must only be partially visible, and CAVA can do this assessment for you and give you a clear indication if the cylinder is visible or not. In some countries, that's a legal requirement that cylinders arranged directly around the vehicle with 1 meter height must be visible, either by direct vision or by camera or mirror vision. And yeah, if there is a blind spot, it must be smaller than a given size. So in CAVA, this is very easily, and you can get feedback about the blind spot and also detailed feedback which parts of the cylinder are visible if you want to do optimizations to your vision system. Another interesting aspect is also the so-called observation cam use case. So observation cams are cameras mounted in the interior of the vehicle, and they are designed to make, to watch the occupants. On one hand, it can watch the occupant to warn him if he falls asleep. So if the eyes are going down, it will get some bell or alarm sound to wake up. And other use cases are the driver wants to see what's going on in the back of the car. The kids are nice or not, and all these kind of information you can put him on a monitor. And here the challenge to the automotive engineer is to place the camera exactly, and it's not easy to get the view right. So with CAVA, this is a few clicks. You just place the cameras, can rotate it. You have a view, like a view on the mirror, on the monitor, and you can easily rotate it and get out the best placement and direction for your camera system. Okay, before I come to the next use case for cameras, which would have a legal aspect, so a legal requirement, I would come back to the legal requirement for the rear view mirror on vehicles. So this is pretty much regulated in different standards, ECE, FMVSS, and also GSO standards. And here CAVA has a function for the rear view mirror, which exists since the beginning of CAVA and is always developed further. It gives you all information you need to make adjustments, to design a mirror, to evaluate the result of your mirror, to even bring a virtual homologation of the mirror. All these documents CAVA produces here are usually accepted by certifications agencies, as a virtual homologation. And yeah, it's the function here brings with it it displays and creates the required vision field. This is the area on the road that needs to be visible. In practical cases, this is actually tested on a projected screen behind the wall. This is the blue area you see left to the vehicle in the picture. And this area must be completely within the visible in the rearview mirror, and it might be obstructed a little bit by the vehicle, but not more than a given percentage of about 10 or 15%. And yeah, CAVA will exactly do this calculation for you, and it gives a clear indication with green check marks if the regulation, this mirror fulfills the regulation or not. And it gives you all feedback and graphical visualization so that you can document that for the homologation process. Now, the rearview mirror is practical today in cars, but it is now changing. So camera monitor systems are now allowed as a replacement for mirrors. Basically, they must fulfill this, at least the same requirements, at least with respect to the vision field. So yeah, we have the requirement that CAVA can also be used to assess this legal requirement for the rear view, and the camera field of view function can do that for you, very similar to the mirror function. It will create the required vision field. It will, after placement of the camera, it will show you the visible area of that instruction field and the blocked area, and it gives you a numerical assessment if the required visual field is achieved or not. So very similar to what we have for the rearview mirror is now available also for the vision analysis. But the camera monitor systems are still in challenge with the mirrors. It's not clear which the customers prefers more. So there's also some news in the CAVA mirror area. There is a new regulation that allows to have a non-spherical mirror. That means you can create a different shape of mirror that allows you to create smaller mirrors, which is also desired by the OEMs and mirror manufacturers because they have less aerodynamic drag. And we have in the last release enhanced the CAVA vision mirror function to instead, in addition to the spherical mirror, allow the toroidal shaped mirror. Means a surface that has two radius, one horizontal, one vertical. And the minimum radius that is required for this mirror is then the average of the two radius. Though the designers can use a smaller radius in the vertical direction, and this allows to make a smaller mirror in the vertical direction. So in practical examples, you can save about 9 to 10 millimeters, which is really a lot in that area. So next, I would conclude the use cases for the camera vision in CAVA, and just to show a small video so that you can see CAVA live in action. So what you are currently seeing is the CAVA product. And CAVA product is a known workbench in CATIA or an app in 3D Experience. All the functions of vision, for example, are grouped in one toolbar. And now you would see some examples like here. One example of the vision field on the windscreen, which has some specific legal aspect. It must be white, 100% clear, for example, the smaller field. And creating this surface here by the given standard is very simple. Few clicks, and also benefit if you change the standard easily with one click, you have the vision fields for a different standard. Other vision requirements for the driver to the front are the apilar obstructions must not exceed a certain angle, and this is a complicated procedure to construct, and with CAVA you can easily do that with a few clicks, just selecting the pillar geometry, and you get the resulting angles and checked if they are okay. Other requirements are there are some areas that the driver must see unobstructed. They are all, for example, these corner points, the so-called the vision points. And in the next, now you will see some angled planes. They define a zone where the view of the driver to the front must be completely unobstructed. Or if there's an obstruction, it's only allowed in a certain area and must be smaller than a given percentage. So all these questions CAVA can easily answer for you. It also can analyze the optical properties of the windshield. It's a double angle and optical distortion. So these are optical parameters derived from the geometry of the windshield, and CAVA gives you an indication if it's within the allowed limits. Okay, I talked about the rearview mirror already. Now you see it in action, how it will really be applied. You have different panels for parametric input of the mirror. You have a result page. You have some graphical viewers to show a view on the mirror. It also gives some additional measurements, so you have an indication how well the required field fits into the mirror. You can use this for all types of mirrors, left, right-hand side, also for the interior mirror, rearview mirror. Here typically also you have to consider blocking elements from the interior, like the roof liners or the headrests. So all these objects can be displayed by CAVA, and you give a clear indication if the blocking is too much or not, and if the instruction field is in view or not. Other vision analysis include checking for specular reflections on the windshield. So if you have a shiny object, it might disturb the driver in the windshield. And with this function, you can also assess if such an occasion occurs, or such a speculation occurs in a window. Other analysis for the direct view answers you questions like, what part of the instrument panel or of my cockpit is probably blocked by the steering wheel, or a direct vision of the driver to the front. You also can visualize where the blockage of the A-pillars or the rear of the interior rearview mirror are. And this helps you to assess if, for example, the traffic light is in the vision area of the driver or not. In this case, it might be visible by the left eye, but not by the right eye. So this kind of ambinocular vision or multi-eye vision can be handled in these direct vision functions of CAVA. Okay, now this is an example of the forward-looking camera. You see the camera vision cone, what it can achieve, or here an example of the legal requirement for the rear view camera. So if you have a camera instead of the rear view mirror and you place it in a certain position, you can easily assess which parts of this area are blocked by the vehicle. Now you see an example of the close range vision, where the legal requirement is to see all cylinders arranged around the vehicle in direct contact with the vehicle. CAVA can detect the blind spot. Here it detected the blind spot, but it's still okay because the blind spot is smaller than a given requirement. And in case you need to have a more detailed analysis, you can visualize really in detail which parts of the cylinders are visible and not visible. Also here for the rear view camera, in this arrangement, the frontmost cylinders, or the cylinders closest to the car, need to be partially visible, and CAVA evaluates if the vision, if this part that is visible is large enough. In this example, you can see how CAVA can calculate daylight opening diagrams and blockage diagrams easily. So that was a quick run through the CAVA mirror, but if you want to see that again, yeah, similar videos are available on our homepage, so you can look and find this information of detail as well here. Okay, now I'm moving to another area of CAVA. It's a CAVA safety module that handles, and one part of that module is the safety of pedestrians. Here CAVA can help you to prepare crash simulations. Crash simulations are a very expensive element of car development, so customers always want to move as much as possible onto the digital model. And CAVA here really helps you to create all elements that are relevant according to legal standards like the ECR 127 or also the Euro NCAP assessment program, where you want to get as most star rating, or you can get a star rating. And of course, during design, you want to ensure that you get a good star rating. So what these commands or these functions can do for you is determining the impact zones. So there are impact zones for the head impactors, leg impactors. And so the designer, the vehicle engineer will get immediately feedback where these impacts will happen. And he can already, by avoidance of putting, for example, hard objects below the hood in that area, make some good design judgments. And yeah, finally, if you want, the customer wants to do a simulation, all these markups that CAVA creates, he can transfer easily to a simulation system, which then could also assess further parameters like the head forces on a head during the impact on the vehicle, which are important parameters for the good star rating. Okay, now, yeah, and in the latest CAVA release, we have added enhancement to that function. So there are new regulations for the so-called vulnerable road users. So there have been additions made for the impact zones on the front of the vehicle regarding to bicyclists. So the zones have been changed, and also the impact points for the NCAP test have a larger zone, and there are specific bicyclist impact points, and CAVA can create this in the latest release, and that makes it easier to create these impact points for the designer. Now I'd like to show a small overview about the capabilities of the CAVA safety radius module. Besides the pedestrian protection, CAVA here helps you to assess the problem of minimum radius. So there are minimum radius required all over the vehicle in different areas. There may be different radii. There are some zones of interest that are more important than others. So all these elements, so-called floor line, and can be assessed with this function, and CAVA will, based on input of the to be analyzed geometry, find critical elements that are below the radius and are contactable with the 50 millimeter radius sphere. All these points are relevant for checking, and it's very hard to find these critical points manually, especially in complicated areas like cooling grills, and CAVA can do this analysis for you, and it will mark up any potentially critical area, either with red colored points or a color map. And based on this feedback, you can do a deep dive, and create more detailed information about that critical point. You will get the radius. You will see how the test sphere would contact the element, and you can create a cross-section view that helps you to document this certain, in this case, this violation of the regulation. And maybe the design needs to be changed, and so during the process, you can repeat this and make sure that there are no critical issues. Same regulation is also for the interior. So especially the head impact on the dashboard or also on the door panels is regulated by ECER 21. There's a so-called head impact zone. Here you see it in the magenta lines. There's an exclusion zone around the steering wheel where the airbag is. And these zones are calculated with the help of a pendulum, which is moved against the dashboard. And the areas contactable by this pendulum make up the so-called head impact zone, where specific requirements are available. So these head impact zones can be created for all seating positions on the instrument panel or other objects like the door panels or seats as well. And other functions in the safety module help you if you have a radius violation. There may be some exception rules which requires you to measure the projecting height of this critical radius, which is a complicated or time-consuming effort to create these sections and do the measurements. CAVA can do this with very few clicks, create a lot of sections, and provide the key parameters, the key measurements as a result in parameters and also in the markup picture. So here now you see the mentioned pedestrian protection zones. You can create all elements mentioned in the standards or in the NCAP regulation. And based on the input of the geometry, CAVA will create all these markup lines, which make up the head impact zones, like the adult head impactor, child head impactor, or the leg impactors. And it helps you also to get input parameters for physical tests, like impact angles and impact energy, which you have to use for the physical impact tests. So you can get an export table, which you can easily use to set up the real-world tests that are still required. From the pedestrian protection, it's also easy to create such a heat map to the engine. It's always a critical area if you have a hard engine part close to the hood. So this would have a hard impact on the head of a person, of a pedestrian or other vulnerable road user. And so this is information the vehicle engineer can use to make good design decisions with respect to the safety of the pedestrians. Okay, I think that was a quick run through the safety functions in CATIA, in CAVA. Now I'd like to move on. I'd want to mention, even if it's not a safety or vision related function, it's a nice addition we had to the new CAVA release. It's in the mannequin module. And one challenge designers have if they place knobs or switches in the interior of the vehicle, they must ensure that it's within good reach of the driver. And to do that, there's some best practices, SAE J827, which helps you to define that. In this, an envelope is created or defined, which lets you assess if an element is within the reach of the full hand, or maybe just a 3-finger grasp, which is a little bit further out, or even just the extended finger grasp, where you can push a button but not operate a dial, for example. And all these zones can easily be created by CAVA. It's available for all these use cases in that standard, which contains different seating belt or types, might restrain you during your reach, different population mixes, and some seating parameters that we derive from the already existing seating parameters in the CAVA base data. Okay, now I talked a lot about homologation in CAVA, but of course, CAVA is only directly available in the CATIA V5 or 3D Experience platform, which is very well good for these users. But there are other users out of the world that use other CAD systems, and of course they have the same problem. They need to have feedback for their homologation process, want to assess these assess the legality of the vehicle against their standards. And the solution for that is the LiteCar product. So we have the product suite in CATIA, and LiteCar is a product specifically designed for the homologation in that area. So this is a standalone product that comes with its own geometry kernel, and you can import JT file formats. So JT files are widely spread among other CAD systems like Siemens NX and others as well. And we have similar, or there's actually a subset of the CAVA functions is available in LiteCar. So basically a lot of functions from the OVA area, from the safety area, and also from the vision area. So this product is developed further, and more CAVA features will be added over time. So that is an elegant possibility to get proven functionality from CAVA also in a standalone project that you can use, standalone program that you can use with other CAD systems. So one of the latest additions also added the safety radius functionality. We saw it in the CAVA video. So the same capabilities like detecting the floor line, finding the reachable areas touchable by this test sphere, and considering all the special exception rules for headlamps and grille checks, and creating visualization for you. So same benefits as in CAVA available in this nice standalone package of LiteCar. So with that, I actually am at the end of my presentation. I hope there were some interesting points for you. And I think now we can open if there are any questions in the panel. I'm happy to answer that.
Okay, thanks, Wolfgang. So as before, you can unmute yourselves now to ask any questions, or you can put them in the chat. I guess I'll start off with one, Wolfgang. So I'm still learning too about all the CATIA products that exist, and I saw that in a lot of the CAVA screenshots. We were looking at CAVA used with CATIA V5. I was just wondering if you could comment on how that changes in 3D experience. So what are all the additional benefits that you could get by using CAVA within 3D experience over CATIA V5?
Okay. So in principle, the basic geometrical features that test the actual legal aspect of the car geometry, they are the same, exactly the same in V5 and V6 or in 3D experience. However, the 3D experience would bring some benefit. Currently in V5 and a lot of the interface to the car parameters. So you can imagine OEMs have a lot of variants of vehicles, and they have for each vehicle variant a set of input parameters. So a current CATIA in CAVA, user either enters these values manually, or they are batch imported from a data set like an XML file or an XLS file. So, and in 3D experience, due to the deep integration in the database, it would be possible to go that direction to manage all these car parameters for each different variant directly in the 3D experience platform in some object, and CAVA could access these parameters directly. So you would have a closer link and a more immediate link, and also the benefit of a single database that holds the real values. You don't have to have transfer problems, have no delays. And so that would be one option we consider, and we are watching closely what customers demand here from us, and we are open to improve the product in that direction, of course.
Okay, yes, okay. So yeah, so we'd see similar benefits on the Daimler side within 3D experience. So that single source of truth. Absolutely. Okay, great. Okay, so is anyone else? If anyone else would like to ask a question, please go ahead. Okay, we have one from James. So, do you have any plans to integrate with libraries of legislative requirements held in 3D Experience Requirements Manager /TRM? That question is also in the chat, Wolfgang, if you want to review it.
Yeah, I think I just mentioned one side of what we could do with 3D Experience is getting the input data, but the same could be you have your specific requirements for the specific car managed in 3D Experience, maybe in that module you mentioned, and all CAVA parameters, so the result parameters, like, for example, an achieved angle of obstruction for the A-pillar, or an achieved underfloor clearance for the slope angle. All these are accessible output parameters. You could already today check with KnowledgeWare, some KnowledgeWare technology, and yeah, that's definitely an idea to also check this in the environment, in the 3D Experience requirements management. So if there are, we are open here for inputs and suggestions from customers as well. So if you have, you may feel free to contact us if you want to go in that direction. So then we could more check out in detail what it means. Then I could answer more deep, definitely. But yeah, good question, maybe.
Okay, anyone else would like to ask a question? Now's your time. Okay, so thanks everyone for joining this.